Assalamu alaikum dear students. Bismillahirrahmanirrahim. Welcome in lecture 23. Okay. This is basically lecture 23. The previous lecture which I will mention that is lecture 25. So I am wrong there. This is basically lecture 23. Clear? Uh, Here in this lecture basically I am ending this session. Clear? The solution of indeterminate beam. I am ending this session here, and in next session inshallah we will start determinate 2D frame. Clear? So basically after finishing that session determinate, we start indeterminate beams, frames, and then we move towards trusses. Okay, after trussing inshallah I will design the beams and frame structures. Clear? So I will also inshallah trying to solve such beam examples instead of these examples that is tricky, that is complicated, so I will share those examples time by time. Okay, so watch the videos, you will get something different. Okay, so we will start this lecture, and inshallah these are the last examples of this session that I will solve. Clear? So we have an indeterminate beam. B and C are rulers. Okay, and A and D are, I think so, these two are fixed support. A and D are fixed. Okay, and B, C are rulers. So you must care about these joints when you are assigning these joints, because in the previous lecture you see that we done a mistake in support D, because that was a hinge support and I assigned that it is a fixed support. So two spans, that is the outer spans, are 5 meter, and this one 3 meter span. So let's see. Units are kilonewton. Okay, let kilonewton meter. We have 3 spans. Okay, and let's say this is 5. We need to edit the grids. Okay, so select spacing. The first span is 5 meter, the second is 3 meter, and the last one is 5, and is 0. Clear? Kilonewton meter. Okay, and okay. Remove this window. 5, 3, 5. This one and this one are fixed joint strand and fixed. Okay, so this is 3, 1, 4, 5 degree indeterminate structure. Clear? We have a UDL there, frame load, distribute it, make sure this is 0. Clear? Modify. Okay, and 20 kilonewton. Okay, is the intensity of loading. Add to existing force, global gravity. Okay, so load are assigned. We will analyze it. Model, do not run now. Save the project. This is example number 27, I think so. So let's see the results. This is a shear force diagram, and this is the moment diagram. So we have moment diagram. Okay, 4.09, 4.09. Okay, so let's see. 4.09 is 3.91. So this is round about 4, and 3.91, this is round about 4. Okay, the maximum is 14 point. So 14 point. At these both are 100% accurate, and you can round it. Okay, these two. you can see your shear diagram. Okay, you can select it. Okay, this is your shear force diagram, and you can see your reactions. These are reactions. These two reactions are okay because the loading is symmetrical, therefore reactions are symmetrical. Clear? So this is example. I am done here, and let's see, I will choose the next example. Okay, so the next example I am attempting is this example. Clear? Right on the screen I am selecting this example from chapter number 12, RC Hebler structure analysis at addition. Okay, there are numerous examples, you need to practice these examples. Clear? So I am solving this example. Okay, this is my example number 28. So I almost attempt round about 12 to 15 examples on indeterminate structures. Now I am done here. Okay, and now this is your turn to show your your efficacy with sap2000. Clear? So you need to practice, okay, and see the results. Clear? This is the example. Let's see, we will analyze it. We have kef feet, or units are kef feet. Clear? Yes. We need to change the units to kef feet. New template. Okay, we have almost how much span? We have 1 span, 2 span, 3 span, and 4 span, and so we need to edit the spacing as well. 4 spans, and we need to edit it. Clear? So spacing, AB span is basically 10 feet. Okay, so select it as a 10 feet. The next one is 20 feet. This is 20 feet. The next one is 20 feet. This is 20 feet. And the last one is 10 feet. Clear? So, okay and okay. This is our required modeling of the beam. Okay, these ends are basically free, so assign it, restrain, these are free ends, so remove the, and you must ensure that this is the sign of, these rulers are the sign of ruler support. Clear? So this B and D are ruler support. Clear? This one and this one, these are ruler support, so assign where this is ruler support, and this one is hinge support. Clear? This one is hinge support. Clear? The loading is UDL plus, and you must note that the beam is symmetrical both with loading and spacing. Clear? So these two spans carrying 1.5 kg per feet loading, this span and this span. Sign, frame load, distribute it, make sure this is 0 because we need to consider a weightless beam. Add to existing global gravity force, and we need 1.5. 1.5. Clear? So this is loading. At this joint we need to assign. Now if you select a joint, then you will assign joint loading. Clear? Joint loading, force, and you ensure, okay, and kf feet, okay, global, okay, add to existing, and here we will apply the moment. So you see this movement is basically anti-clockwise, and the movement is about y-axis, okay, because this is z-axis, this is x-axis, and y-axis is passing through the screen. So this movement is basically about that axis which is passing through the screen, or which is perpendicular to the screen. Those axes perpendicular, that is y-axis. So here we select this one and with a negative sign, okay, because the movement is anti-clockwise. Okay, and here we have also a movement which is clockwise, and that is also 10 kV. So sine, joint load, force, sine, joint load, force, and here we need a positive sign. Clear? Kf feet add to existing. Okay. Now if you want to see the loading, this is anti-clockwise because it is going away from the member, and it is toward the member. Okay, from this side it is toward the member, and from this side it is going away. So this is clockwise. Clear? I mean, if you want to see the your UDL, okay, select this option, and okay, this is your UDL. Okay, so this is your loading are assigned properly, and make sure you are in XZ plane, analyze, model, do not, and run now. So the project, that is, I think so, example number 2028. Clear? So save it and see the result. This is 12, this is 12. The reaction should, this reaction should be equal because the load is symmetrical. Clear? And let's see, we check the result. Clear? So this is shear, this is 12 and this is 12. So the reactions are okay. Clear? And let's check it, the shear force diagram. Select this option. Okay, so this is 17.98, it is around about 18. Clear? 12 and 12. Shear force diagram is okay. And now we want to see the movement diagram. So the maximum movement is 69, that is negative. So let's see, check it. This is 70, round about 69 is around about 70. Clear? 69.58, which can be rounded to 70. Clear? So one thing that you people learn from these videos, these videos are very useful. Okay, these are the basics. You must ensure that these are the basics. You see that you compare the actual results with structure analysis program 2000. Clear? And you must sure that whenever you are doing your PLC designing, okay, you need to round the values, okay, because SAP give you a conservative result, although it gives you it gives you maximum shear force and bending moment, and it gives you a kind of conservative results. Okay, so although SAP results are satisfied, okay, and you need to round such kind like 69.58, so you can consider it as 71, 70. Okay, so it is 38.17, you can round it, approximate it to 39, 40. Okay, so this will be a conservative approach. Okay, and conservative approach. Okay, and I'm done here. I think so. I cover 12 to 15 examples on indeterminate beams. There are so many examples. Clear? And I'm searching for different unique examples which is tricky, so I will do those examples in my coming lecture as well. So this session 2 is basically related with the solution and analysis of indeterminate beams. So basically I try my best to solve the different type of examples, and if you have any question, okay, any doubts, any comments, any suggestions, you can share with me, and you can share those comments with on my email, okay, on my YouTube channels, okay. So watch the video and enjoy. Thank you.